a common emitter amplifier having the voltage gain G, the transistor used has transconductors 0.03 mho and current gain 25. If the above transistor is replaced with another one with transconductor 0.02 mho and current gain 20, what will be the voltage gain? In a common emitter amplifier, the voltage gain G can be expressed as G is equal to minus beta RC into Gm, where beta is the current gain of the transistor, RC is the load resistance, Gm is the transconductance. Since RC or the load resistance remains the same, we only need to compare the changes in beta and Gm, that is in between current gain of the transistor and transconductance, to find the new gain. It's given initial transistor has Gm 0.03 mho and beta is equal to 25. And the new transistor has Gm is equal to 0.02 mho and beta is equal to 20. The initial gain G is proportional to eta into Gm, which is nothing but 25 into 0.03, which is nothing but 0.75. And for the new transistor, the gain G dash is proportional to beta dash into Gm dash, which is nothing but 20 into 0.02, which is equal to 0.4. Now, the ratio of the new gain G dash to the original gain G is given by 0.4 divided by 0.75, which is nothing but 2 by 3. Therefore, the new voltage gain will be G dash is equal to 2 by 3 into G. So, the correct answer is option D, 2 by 3G.